Hello ladies and gentlemen, my name is Mr. EDK, and today I'm going to show you guys how to take an equation from an exponential function and create a graph from that equation. Additionally, I'm going to give you a couple pointers on what to look for in the graph that relates back to the equation so that you can work backwards as well. Let's get an equation written down first. F of x is equal to 3 times 2 to the x power, and this is in our exponential function format, which is f of x equals a times b to the x power. Now I'm pointing this out because I want to be able to know exactly what are my a values and what is my factor of change. So in previous videos I talked about how this is my starting value and b, the number 2 here, is my factor of change, which basically means what am I multiplying by? If you are unsure what a graph looks like, you always start by making a table of values. So I'm going to go ahead and make a table of values, and I'm going to make this quite large because I want to go ahead and incorporate a couple things. The first thing I want to incorporate is x, my input value. I want to incorporate f of x in my calculations here, so 3 times 2 to the x power. And over here in my final column, I'm going to put my output value, which is what f of x actually equals once I have done my calculations. So let's go ahead and see what this looks like. I'm going to choose 3 values, and I'm going to pick some of the easier ones, 0, 1, and 2. And I'm going to go ahead and substitute these values into x of my equation. For f of 0, this is going to be 3 times 2 to the 0 power, and anything raised to the 0 power will always equal 1. So now we have 3 times 1, because the first thing I have to do is 2 to the 0 power before I can multiply. So 2 to the 0 power is 1, which then results in giving me 3. So my output value here is 3. So I always calculate this first before I multiply it out. That's an interesting thing to note, because if you look at the equation, this 3 happens to also be what I told you earlier was my starting value. And lo and behold, if I use my y-axis as a starting location, then 3 is my starting value. So coming over here to 1, this is now going to be 3 times 2 to the first power. Again, I'm going to calculate this first because of order of operations states that I multiply out my exponents first. So this becomes 3 times 2, which is then 6. So my output value is 6. So 1, 6 is my next point. Coming down here to the next number, 3 times 2 to the second power. Again, I'm going to calculate 2 to the second power first, which results in 3 times 4, which ends up giving me 12. So my output value is 12. 2, my output value is way up here at 12. If I went over here to 3, my output value would be 24, which is off the graph somewhere. So this is the point 324. And you can see that it's growing like this, and it's going to become flat in this direction. Now, a couple things I want to point out. I've already pointed out the first thing, one of the more important things, which is here, this 3, this a value, also happens to be my y-intercept. So when you're looking at these exponential functions, this a value, this starting value, is another name for my y-intercept. This factor of change is how the output values are increasing. We are multiplying by 2. So what is the fastest way to find a second point? Well, we know that anything raised to the first power is itself. So if you think of it that way, these two numbers multiplied together, 3 times 2 gives me my 6. 3 times that first factor of change is 6. So by looking at this point and this point, I can go backwards and find my equation. So let's go ahead and rewrite this point. This is the point 1, 6, and this is the point 0, 3. So those two pieces of information are incredibly important if I wanted to work backwards. Let's assume now that I did not have all this information here that gave me my graph, and instead I was given a graph and no equation. So if I'm looking at this graph, a couple things I notice first. First, I notice that my y-intercept is 3. Therefore, I can draw the conclusion that my a value is 3. So now my function starts off f of x equals 3 times something. But what is that something? Well, that something needs to be my factor of change. So now I need to look at my output values. I need to look at how 3 here becomes 6. How do I get from 3 to 6? And that information is my times 2. I multiply by 2. And so I can draw the conclusion just by looking at this 3 and that 6 that my factor of change is 2, which is always going to be raised to the x power because we're dealing with exponentials right now. Ladies and gentlemen, I hope this video was helpful. Thank you so much for watching my video. This was Mr. EDK. Stay healthy and stay safe, and I'll see you next time.